Jai Hind to all. My name is Dr. Divya Sharma, Assistant Professor in Ajay Kumar Garg Engineering College, Ghaziabad. Now, today's video lecture is on PLL, that stands for Phase Log Loop. So, these are the outlines of my presentation. PLL, applications of PLL, that are frequency multiplier, analog phase detector, digital phase detector. Now, after that, we will discuss advantages, disadvantages and limitations of phase log loop. Now, first, what do you mean by PLL? So, PLL stands for phase log loop. It is a closed loop feedback system commonly used in electronic circuits to synchronize an output signal phase and frequency with the reference signal. So, and PLL crucial components in various IC components applications including telecommunications, signal processing and microprocessor. A phase log loop mainly consists of phase detector, active low pass filter and VCO. VCO stands for voltage control oscillator. Now, this is a block diagram of PLL where you have block components like phase detector, low pass filter, voltage controlled oscillator, and here we will get the output frequency. So, what is the purpose of this PLL? In this PLL, output frequency should be matched with the input frequency which is applied at the phase detector. It means here when we are matching this F out is equal to F in, so error, this phase detector is used as a comparator here. So, when we are comparing this F naught and F in, error should be 0 here, So, there is a feedback in between output frequency and input frequency. So, this is the working of this PLL where here we have to match output frequency with the input frequency, error should be 0 here. These are common PLL ICs. LM565, this is used for general purpose PLL IC. Second is CD4046, this is most popular CMOS PLL with a wide range of application IC. Now 74H4046, this IC is high speed version of CD4046 for high frequency applications. Now ADF4 series advanced PLL IC for RF and wireless communication. So, these are most common PLL ICs. Now, what are the applications? Okay. Now, what are the applications of PLL IC? Frequency synthesizer. This is used in communication system to generate precise carrier frequencies. Now, second is clock recovery. It extracts timing signals in data communication system. Now, FM modulation, demodulation converts frequency modulated signal to audio and or baseband signals. Now, the last is motor speed control. It maintains precise motor speed in industrial system. These are the applications of PLL. Now, here first application we will discuss frequency multiplier. Here these are the components of this PLL. First is phase detector. It is used as a comparator here, and loop filter means here is we are using here low pass filter. Low pass filter means it passes all the low frequencies and reject other frequencies. Now, VCO, voltage control oscillator. So, voltage control oscillator, we are applying here input voltage at this VCO and we are getting here output frequency, and output frequency we are matching with the input frequency. This is the working of PLL. Now, here frequency multiplier. Let it be here we are applying 5 Hertz. So, output frequency, if we are using frequency multiplier, it means if it let it be, it is 5 into 5 means 25 Hertz. So, N is a number of frequency divider. So, if we have now here in this circuit, if we have to match this output frequency with the input frequency, it means here also frequency should be equal to 5. But here if we are using this application frequency multiplier, there is frequency it is 25. So, what is the method when we are matching with output frequency with the input frequency? We are applying here frequency divider in the feedback. It means how many number of frequency we are multiplying. Here we are using frequency divider, divide by n. So, that by using this method we can match with output frequency with the input frequency, and this is the purpose of this PLL. Now, second application is analog phase detector. So, here this is a when we are this is analog phase detector. Here is input signal, its input signal Vs, and here is its output signal is V. So here electronic switch is used in between input signal and output signal, and it is derived from VCO. This is voltage control oscillator. Now here also we have to match with output frequency with the input frequency. Now here this is the signal, this is you all know VCO generates triangular wave and square wave. Here we are using output of VCO, that is in square wave. So here this is the square wave 0 1 0 1 like this. So here phase shift is represented by phi. If we are using phi is equal to 0 degree, and we have to find out output voltage for this, phi is equal to 0, it means if square wave is negative, it means your signal is in negative, its magnitude is negative. If square wave is positive, its magnitude is positive, and it is matches at this point 0, means from 0 to 0 if it is negative, so its magnitude is negative. If 0 to 0 it is positive, so its magnitude is positive. It is in the case of phi is equal to 0 degree. If we are talking about the case phi is equal to 180 degree, it means there is a phase shift of the signal. It means if this is negative, square wave is in negative form, so a magnitude is positive, and if a square wave is positive, magnitude is negative, means it is inversely proportional to this. If this is phi is equal to 0, this is the inversion of this, phi is equal to 180 degree. Now here if we are talking about this phi is equal to 90 degree, it means some signal here when we are applying here square wave, then some signal of this output wave is in negative. Here this is some part is in negative and some part is in positive. It means positive and negative magnitude is cancel out, and we will get here 0 error. And our purpose is we have to generate 0 error when we are comparing output frequency with the input frequency. So this purpose is solved by using this phi is equal to 90 degree, because here positive and negative phase are cancel out and error voltage is equal to 0 by using this application analog phase detector. Now the third is, if we have to prove it mathematically, we can take two signals. First signal is Vs is equal to Vs sin omega t, and you all know omega is equal to 2 pi fs. So you can put here the value of 2 pi fs in this signal, and this is your input signal, and by VCO signal your signal is V0 is equal to V0 sin 2 pi f0 t plus phi. Now output of this phase detector is equal to Vc is equal to K. K is here phase comparator gain, and we have to multiply these two signals, signal 1 and signal 2 which is generated from VCO signal. So Vc is equal to K into Vs sin 2 pi fst into V0 sin 2 pi f0 t plus phi. So we have to multiply these signals, we will get here, and here this K term is K is phase comparator gain, and phi is the phase shift between the input signal and the VCO signal. Now we can apply here, this is sin A and sin B signal. So we can apply here the equation that cos C, here sin C into sin D. So we can apply here formula, mathematically we can solve it like cos C minus D or C plus D, right. So Vc is equal to K Vs into V0 upon 2. So here apply the formula and you will get here cos 2 pi fst minus 2 pi f0 t minus phi minus cos 2 pi fst plus 2 pi f0 t plus phi. Now here by locking condition we have to apply Fs is equal to F0. So in this equation you can put Fs is equal to F0. Then only if we are replacing this Fs is equal to F0, then only this term is and this term will cancel out. So you will get here when this term and this term is cancel out, you will get here cos minus phi. If here we are replacing this Fs is equal to F0, so you will get here 4 pi f naught t plus phi. Now final equation is Vc is equal to k Vs V naught upon 2 cos minus phi minus k Vs V naught upon 2 cos 4 pi f naught t plus phi. So this is a this is the DC term where phi is equal to 90 degree, then cos phi is equal to 0. Now here this is double frequency term, and in this PLL here we are using low pass filter. So low pass filter means low frequencies are passes and other frequencies are rejected. So here is a double frequency term, so we can reject this term and we'll get here this term Vc is equal to k Vs V naught upon 2 cos minus phi, and if this is a DC term, so when we are putting phi is equal to 90 degree, then cos phi is equal to 0. It means error is here 0. So we can prove it mathematically also, that when we are comparing output frequency or we have to match output frequency with the input frequency, then error should be 0. Now here double frequency term is eliminated by this low pass filter and DC signal is applied to VCO. It is clear that DC term is error and DC term is error removed and only when phi is equal to 90 degree. Thus VCO output and input signal Vs should be 90 degree or out of phase for a perfect lock condition. Now third application is phase detector using XOR gate. Now here you all know this is an XOR gate. A, B are your inputs and Q is the output for this XOR gate. And here if we are talking about in terms of PLL, so A is an input signal and B is the VCO output. So our digital phase detector is basically an XOR gate which produces a high output if and only if any input is high in the case of any of these two inputs. So this is the truth table of XOR gate. A and B are your inputs. A is the input signal, B is the VCO output. This Q is your output. So we have to find out, and you all know the equation for XOR gate. Q is equal to A B bar plus A bar B. So when you have two inputs, how many combinations are there for two inputs? 4 combinations are there: 0 0 0 1 1 0 1 1. Now here if we put here A and B values 0 0, so Q is equal to 0 here. And when we are applying here A is equal to 0 and B is equal to 1, then Q is equal to 1. It means from this truth table we can put this value 0 0 0 1 1 0 and 1 1. If both inputs are same, then output is equal to 0. If any input is different from the first signal, then output is equal to high. Now we can show it graphically. Input signal is, this is plus minus, this is your input signal and this is output signal, and you can see this VC output, this is shifted from here, this is 0 to 0, you can see this is positive and this Q is shifted from, this is the phi angle. So this is shifted output, VC output. Now error is here, error is this much. If we are taking difference of input signal and VCO output, so this is the error voltage which is produced when we are comparing the output frequency and the input frequency in this case of PLL. So this is the application of PLL, that is phase detector using XOR gate. Now these are the advantages of phase log loop: stable frequencies. So this one is the advantage, that precise frequency generation for communication system. Now second is for data synchronization. So it recovers clock signals for digital systems. Now third one is noise filtering. It reduces signal noise effectively. Now fourth one is versatile application. It is used in RF and motor control and communication. Now the fifth one is self-adjusting. So it adapts to input signal variations. So these are the advantages of phase log loop. Now these are the disadvantages of phase log loop. First one is noise sensitivity. Now susceptibility to system noise affecting performance. Second is complex design. So it's challenging to implement for high frequency systems. Now the third one is high power usage. So it consumes significantly power in fast applications. Now the fourth one is limiting range. Now it works only within a narrow lock range. Now the last one is also the disadvantage of PLL, that is temperature issues. So it varies with the temperature changes. So these are the disadvantages of this PLL. Now limitations of PLL. First one is narrow lock range. It limited frequencies range for phase lock. Now the second is slow lock time. So it takes time to stabilize in dynamic systems. Now it is also used in temperature effects. The performance varies with the temperature changes. Now the fourth one is non-linear components. So it's sensitive to imperfections in VCO and phase detector. Now the last one is noise vulnerability affected by high frequency noise and impacting stability. So these are the limitations of phase log loop. Now these are the references of this topic. We can refer this linear integrated circuit, 4th edition by D. Roy Chaudhary, and operational amplifier and linear integrated circuit, 4th edition only, that is for Gaikwad, and you can explore this link also for this PLL, and this is also a link which is given here. We can search out about this PLL. Thank you.